Welcome to our next session. This panel is on sustaining orbital space as a resource. Commissioner Gomez talked a little bit about some of the issues here. I wanted to give just a quick introduction of some of the issues and then introduce the panel and move into the questions. So as Brad stated earlier, space may be infinite, but near-Earth space is getting crowded. As of last April, there were on the order of 12,500 satellites in orbit, and over 3,000 of these were inactive. So right now, 2,800 satellites were launched in 2023, and about 200 a year become inactive. So the numbers are working to make space ever more crowded. And I looked up a couple of other little factoids. And at this point in time, there's like 128 million pieces of debris and satellites that are in orbit right now, with a combined weight of over 10,000 tons. So can we sustain this as a resource? So we've got a very incredible panel here, I think, to discuss some of these issues. So immediately to my left is Jillian Quigley. She's an associate at Wiley Law and is a space lawyer. She's co-chair of the Space and Global Communications Committee at the Federal Communications Bar Association. Next is Milo Medin. He's the founder of Logo Space Services, which is building a new dual-use low Earth orbit satellite constellation. Next is Jonathan Skinner-Thompson, who is an expert in environmental law, which is, it's an interesting analogy to bring to our space resource issue. And at the end of the table is Abbud-Madrid, who is the director of the Space Resources Program at Colorado Schools of Mines. So let's give a hand for the panel. And let's get started. So I cited some figures about how crowded space is getting. And so my initial question is there a limit to the carrying capacity of near-Earth space? Is there a practical limit to the number of satellites we can get up there at the same time? And if so, what kind of regulations are needed to deal with this issue? I guess I'd like to start with Milo, actually, since you're launching.
Well, a couple years before we launch, but I remember this conversation I had with General Paul Selva, who was the vice chair of the Joint Chiefs of Staff. He was a air mobility command pilot. He was a C-17 pilot. And he was telling me the story about transatlantic air traffic control. Because originally after World War II, you had airlines starting to fly across the Atlantic, and they had very high spacing between them. And the reason for that was they didn't have comms. And then you had HF radios and you had oceanic control, and that allowed you to pack more and more together. And one of the points he made was, now with GPS and with highly reliable satellite communications, you can actually, the amount of air traffic going across the Atlantic is a huge multiple of what it once was. And I think there's a lesson there for space as well. That is, to the extent that we have knowledge of where objects are and more precision and can predict trajectories, which, the lower you go, the harder it is to actually predict. Your drag line gets higher, and so it's a little harder to figure out where things are going to be. But I think if we have better space situational awareness and the ability to understand where things are with high degree of precision, that should allow us to actually be able to fit more things in. Altitude is one of the things is driven by mission primarily, right? So you might want to spread things out, but there's certain altitudes where instruments, radiometers, et cetera, and comms work best. So I think part of what we have to do is think through the issues of how do we get better precision of where things are so that we can avoid them. And also the dynamics of, how do we actually make that information available so people can take action and plan accordingly. There's a big transition going on between the Department of Defense to the Office of Space Commerce. others could probably talk about that. That's probably going to be a slow transition, but I think the reason for that is to make civil space navigation much easier to plan and deal with.
Thank you. Jillian, do you want to take it?
Yeah,
take it
no,
back
and
at that?
I definitely agree, and I think OSC is doing a great job at building tracks, which is what
Right.
they're calling their space domain awareness program. They're essentially trying to tell everybody where everything else is. And I want to add a little sci-fi element to this, just because that's one of my favorite things. Not only are we thinking about things that are currently orbiting that we have to avoid, but in the future, when we're going out of orbits, we also have to think about how are we managing that kind of traffic when there is also traffic that's going across. And I think it's interesting when we try to look at other international frameworks. This seems kind of unique to space in that we don't really have the same issues with airspace or
Right.
with like international law of the sea, where there are things that are autonomously moving in an orbit, and there are also things that are moving through orbits. And so we do sometimes encounter this, like for example, geostationary satellites. Like we do need to go through LEO to get to geostationary orbits. And so I think that in the coming years, it's going to be important to really think about how we're shaping regulations to ensure that we still have pathways to get through LEO and to get through the outer orbits, to get to the moon and to get to Mars, to get to pretty much anywhere else.
Thank you. Jonathan?
So, yeah, no, thanks for having me. As mentioned, I'm an environmental lawyer, so I've thought about these issues in the context of pollution control, and I wanted to share a little bit from the 1960s when environmental issues were at the forefront of our political thinking and socially speaking. And there was this group called Resources for the Future, which some of you might be familiar with. They're an environmental economics think tank, and they put out a report called New Resources for the Urban Age. And what they were trying to do was think about how should we approach the pollution issue, air quality, water quality, but they also listed spectrum as one of the new resources of this age. And they said, or concluded, that we need to start thinking about air quality, water quality as a congestion issue, which sounds similar to what the issue is here with space, that's getting too crowded. And if we think about it as a quality issue, a congestion issue, rather than a supply issue, because space is infinite, air is infinite, the air that we breathe, for instance, but it's getting dirtier. It's not as usable because of congestion. And one of the approaches to dealing with congestion is we need management. We need to better understand the resource. We need to have experts who can monitor better, who can track all of the satellites that are in space. And so there are different ways to come out on the management side, whether we want to leave it to private ordering, whether there should be some supranational agency, whether nation states should do it. But I think there are a lot of similarities that we can, or lessons we could learn potentially from how environmentalists have approached somewhat similar issues, and we can talk about that a little bit more differently, but it's not all potentially that new.
Angel, any thoughts on this issue?
Actually, in terms of how many satellites you can put out there in capacity, I think my colleagues can answer that much better. I focus on space as a resource, and in fact, it was the very first resource that we utilized from space. If you look at Telstar 1 in 1962, it was the first time that we realized that space could have a value, could have an application. And that's when the whole communication satellites revolution started. So we see it as an asset, but obviously, increasingly, we're seeing this also as an issue. So I worry more about what to do when these things get more crowded and how we can utilize this as a resource later. So I'll probably comment more on that aspect.
Okay, thank you. So you mentioned some interesting things about watching orbits better and trajectories and so on, but how do you regulate this and enforce it? Okay, is there an international authority? How do we get nations to cooperate on this? So I'll toss that to Jillian first.
Yeah, so there's a couple different international frameworks. So in terms of managing orbits and managing spectrum rights, there's the ITU, and they do a large amount of the just spectrum, and that also includes orbits because those are intrinsically tied. And then you have UNUSA, who helps with the space object registration pursuant to the registration convention. And then in terms of liability for this kind of space debris, like how do we keep actors from doing bad things? We have the liability convention, which is tied into that, into the registration convention and the other international legal frameworks for space. But I mean, on a more basic level, in addition to those, we have, it's a double-edged sword, because when actors do bad things in space, it often does have blowback on them as well. And so one of the examples is the Russian ASAT tests a couple years ago created.
Acronym.
Oh my goodness, it's anti-satellite test is ASAT, yeah. And so they essentially shot a missile into space and blew something up in space. Generally, the international community does not look fondly on ASATs just because it creates a lot of space debris. They don't, yeah, it's very bad, very bad. We don't want it. And so the ISS recently has had to do a lot of evasive maneuvers because of this new space debris that was created. Incidentally, a lot of Russian nationals are on the ISS quite often. And so a lot of the time it kind of disincentivizes actors to do things because they often have to deal with the consequences just like everybody else.
Yeah, I think that's exactly right. Especially if you think about operators like SpaceX, like us, like others, who are putting multiple satellites in plane. If one of your sats dies, you're the one who's the most likely to suffer as that orbit begins to degrade, and it's more likely to bump into you. Now, if you've got a dozen sats all in different inclinations, well, you're probably not going to run into yourself. So there's a different dynamic there. But I think for the folks who are building these constellations, we're the ones who are really focused on making sure we don't mess up our own orbits.
Okay, and I've got to go to Jonathan next, because this international resource collaboration just seems like the analogies to environment is.
No, absolutely. And so I might before getting into that, take a step back just to provide two different contexts in which we might address this issue. There's the international sphere, of course, is how do you get the nation states to coordinate with each other and the private actors, because international law tends not to directly address private actors. They have to go through governments. And then there's also the domestic legislation or the domestic regulation, that's where you often see most of the international requirements being implemented, or we see some more of the bite on private actors is how do those national governments regulate these individuals or these parties. And I think there are issues with both. The international side is how do you get the nation states to cooperate? Who are the big players? Is it really just a handful of countries that are launching satellites into space, and so really you just need those countries to work together to agree? How do you get Russia and the United States and China to agree currently on the use of these resources? There might be some analogs to that. The Arctic, for example, is an area where you have these major players constantly butting heads with one another, trying to claim more of the polar resource. So that seems like an appropriate analog. But then domestically, how should we design a scheme, a regulatory scheme that best addresses the problems that we have with space? And the problems might be too multifaceted. It seems to me, and I'm not an expert here, but there's the spectrum issue, which is congested lines, and then there's the debris issue. And those might be addressed differently, because one looks more like a toll road situation, I think, and the other one more the quality of the area. It's getting congested with space debris. That seems more like a traditional environmental problem. And under domestic US environmental law, we've dealt with those types of problems in different ways. One, and maybe we'll get into this a little bit more and I can jump into that, but one approach is to think of it as we do with the air. We set objectives, a goal, a quality objective, and say this is how much debris we're willing to tolerate. And then we'll regulate down from there. Who has access to it? Who gets to put in a new satellite? What are your obligations for your expired satellites or shuttered satellites, the ones that have run out of gas, et cetera. So we can come up with different regulatory regimes to address those problems, and there are different incentives that come into play, and I can jump into that a little bit more later as well. But I think one of the big questions is, do we want to focus first internationally, domestically, and how do they relate to one another? And there are a couple of international regimes. The law of the sea is a great example as one where we can borrow a lot of that history.
So you want to jump on that international issue?
Yeah, well, yeah,
We
so,
were
and I
talking a little
think,
bit about that earlier.
I think there is a link between the domestic regulatory regimes and the international legal frameworks. And some of it does have to do with using the states as the main legal channel for some of these issues. And so all of the operators who are launching in the United States, although the United States doesn't always claim itself as a launch state, they often say like, we're registering this, but it's not ours. So the launch state concept is really important in liability. And so oftentimes what happens is the state that is responsible for causing damage or causing debris is the one who's held liable, and then that gets passed on to the operators. And so there kind of is a channel where we can use it, and I think the law of the sea is a really good example of that. It's also used for flag states. In law of the sea, if there's pollution or if there's other damage, it's passed on to the state, and then it gets passed on to the operators.
Yeah, this is quite an interesting topic because you can then expand it to what was going to happen a little bit more into the future. You alluded to that, Jillian, a little bit about what happens when you start going beyond LEO and GEO orbits. Right now, the United Nations Office of Outer Space Affairs, says now considering it has a subcommittee on space resources, and it's going just beyond just space as a location resources. Now it's looking at energy and solar and lunar resources and the like. And just a couple of months ago, they got together to discuss these type of things. What to do. If you're worried about debris now, think about what's going to happen once you start trashing the moon with all sorts of landers that are crashing these days. This is going to be an issue. And how do we go beyond the way that we've been handling enforcement these days, which has been practically what happens at the United Nations is name and shame. Somebody did something wrong and you point fingers and somehow the situation is solved. But as we keep going further out into more exploration, moon, Mars, and beyond, this is going to get a little bit more complex. And now you have not just space agencies, you got private actors, and you're right, you have to go through your country, but how do you establish the rules of how to behave in space is going to become increasingly important.
To kind of emphasize this, I do think that there is a really important role that the industries have to play, and I do think that there needs to be more diversity of entities involved at the international level, because ultimately, at the end of the day, the industries are the ones who are making these changes, and they're the movers and shakers of these technologies. And so to some extent, even though the governments might be responsible for being the main liability channel, I think that there needs to be a lot more ability for the industry to be able to participate in a lot of the norm building and the regulations, both domestically and at the international levels.
Which you can't at this point because it's just countries getting together. They do listen to some comments, but industry and the private sector is not actively involved.
And I'll just jump in on that point. In the environmental context, we've had similar issues again, and different outcomes. So looking back on the stratospheric ozone hole, or not the ozone hole, industry was a major player in negotiating those treaties and those agreements. Absent industry support for the ozone depleting substances bans, I don't think those treaties would have gone through. So that's an example historically where we've seen a very successful treaty outcome because industry was willing to play and because countries were listening to them. We've also had multiple examples on the other side where with climate and with the plastics negotiations currently, or trying to negotiate a global plastics treaty, there have been big critiques that industry has prevented any type of international agreement on that side. So knowing how industry fits in, obviously key players, but how they fit into the negotiations can lead to different outcomes too.
So what are the forums for negotiating these regulations? What are the organizations that we have to work with? Kind of a question out of the blue here that you just made me think of as we're talking. I mean, the ITU is one, but they're mostly doing spectrum. There's no similar organization to the EPA internationally for space, though.
No, and I think international relationships are not in the best place that they've been in a while. So, I mean, I think the question is really about maybe rather than treaties, at least having actors set norms is something that you can do without necessarily having formal international relationships. And I think that may be the path forward for the folks who are the most active in this area and have investment that they want to protect.
And to add on to that, international law has a few different layers. One of the primary layers, because treaties are incredibly difficult to negotiate, is what's called customary international law. And that is this type of law that exists, that parties follow and that states follow, that is developed out of custom and out of norms that we've built. And so just because there aren't treaties in place or treaty bodies that handle these issues internationally, doesn't mean that there are rules of the road. And so just because it's not written down on paper, that doesn't necessarily mean it doesn't exist in practice.
I think the UN Law of the Sea actually is a good example where, assuming there is some framework treaty that gets put into place, maybe for space, in building that treaty, you can incorporate, at least the way the Law of the Sea works, is generally recognized international rules and standards, which can come from other agreements that aren't necessarily treaties. And so it's like allowing or creating a way to incorporate customs, practices of the community, of industry, of other nation states, without having to put it into the treaty. Because as was mentioned, it's hard to negotiate a treaty in the language of the treaty, but there are ways to build a treaty that allow you to incorporate some of those future developments, especially in an area like space where technology is evolving very rapidly. And it's going to take too long to come up with a treaty that's going to be able to address every single new development. So if that's the approach that's taken, where some framework treaty is developed, it might be useful to have those outlets.
So we talked about debris a little bit, and Angel brought up the issue of littering on planetary bodies and so on. There's also an issue of littering in space. Right? I mean, a satellite has a finite lifetime. It's only got so much fuel and so on. What do we do with used satellites? I mean, do we leave them at the side of the road like a car?
I think it's not just the satellite itself. You've got parts from launchers. Not everybody has reliable launch like SpaceX. Let's leave it at that. There have been boosters that have shed parts all over the place at relatively high altitudes. You've got the deployment mechanisms. There's a lot of care now being put into place so that we don't have little parts when a satellite is ejected from the vehicle. Those little parts are hard to track. Arguably, they're worse than satellites to deal with. So how you do the mechanical design of the launcher, any bus integration or the spacecraft, so that when things are being deployed, you don't have pieces that are left. And that's really intentional work that has to go on. And I think the US has done a pretty good job in working in that area. With regards to satellites, I think, as I said, if you've got dead sats in your orbit, that's a problem for you, right? For us, I think we'll do the same thing that SpaceX does, which is do insertion at a lower altitude, turn everything on, and then climb to the target altitude with electric propulsion, with EP. So if you've got something that dies and sort of early failures, you can then re-enter, or it'll get eventually come down without a lot of, without many, many years. And so if you can get the sort of early failures taken care of, that's a good thing. But, you know, even for geo, parking orbit, like you're putting things in there that are going to be there for a very long time. Right now, that's not a problem, but over time, you could imagine those orbits potentially becoming more usable. So this is a problem we all have to deal with.
I brought some fun facts about space debris, like you mentioned. There's a lot of space debris, and it's not only satellites. Between 1 and 10 centimeters, there's about 500,000 fragments in orbit. 10 or more centimeters, about 34,000. Under 1 centimeter, 120 million pieces. And you can't track them. And so if a 1 centimeter, 10-gram piece of debris hits something, it has about the same amount of explosive force as a hand grenade. And so
1/2 MV squared, right?
yeah, it's teeny. It's a teeny tiny piece of debris that we can't track that's going to be hitting something. And often that's incredibly hazardous. And so that should also be factored in addition to satellites. There are a lot of companies right now that are doing some really exciting things. So some companies under what the FCC is calling ISAM, which is in-service manufacturing and in-space servicing and manufacturing. So they have various types of bodies. So there's a spacecraft that will go around and collect debris. There are a couple companies that are testing out refueling mechanisms and using like tiny nozzles on the satellites to put more fuel in so that we can extend the lives of those satellites. Because one of the things that we need is fuel, and that's often a mission limitation, especially for geostationary satellites. And then there's other types of mission extension vehicles that can kind of, once the satellite is almost defunct, they can kind of move them. I call them like tugboats, almost. So there's a lot of really exciting things that are happening right now as we speak that are about to be launched or that have just recently been launched that are helping to remediate some of these issues. But at the same time, we can always do more. The FCC is doing a great job at helping that happen, but there are a lot of really difficult aspects of it, especially because of orbits and because of spectrum rights that we can't always innovate in the way that would be best. And so more flexible regulatory schemes are always something that would be welcome for this.
And I think that, I mean, we can talk about remediation later, but I think you touch on a very important point. How do you at least mitigate? And what is happening right now on refueling is a very important part. I mean, we have a company right here in Colorado, Orbit Fab, that is trying to do that, even has a contract with the US government on how to start refueling spacecraft. And this is important not just for companies, but also the military is quite important. According to their maneuver without regret philosophy that they have, this is a way for them to be able to move satellites and move quite rapidly, and that can also mitigate the effect of space debris. And as we speak, you know, there's a Chinese spacecraft that is testing refueling in space. It was launched last week. So this creates also geopolitical tensions that people are advancing very rapidly on see how they can refuel in space and in a way, in a secondary effect, could mitigate some of these aspects of space debris.
So one of the issues that we've had in with land pollution is with orphan
get close to the
wells.
mic.
Sorry. One of the issues we've seen with land pollution is orphan wells, abandoned oil and gas wells, or slag piles from abandoned coal mining operations. The liability for cleaning up those sites often falls to the state, in this case, the state governments. And there's potentially an analog here with space. The liability is falling on nation states if you have a maybe a defunct company that's no longer around to pay for the cleanup. And there are a couple of different ways state governments have tried to approach this issue. One is that new operators, new oil and gas, new coal mining, or any mining really, they put in financial assurances or insurance requirements so that if those companies go defunct, the bill doesn't fall on the government. And so that could be something to consider here, where you have new operators launching into space, and maybe they would at least put up some money so that the national government isn't ultimately responsible for it in the end. But then you can also incentivize recycling. Pennsylvania did this with its abandoned coal waste piles. They actually created an incentive scheme that allowed companies to burn used coal waste. They didn't have to meet the same regulatory requirements, the same air pollution controls as other coal-fired power plants. And so there were some environmental costs to it, but it at least incentivized the use of these abandoned coal piles. And so there may be a way to incentivize companies to go up into space and start collecting some of these abandoned satellites or debris by lifting some regulatory requirements or providing a financial incentive. And then the other regulatory scheme that I might throw out there for consideration is what we call the Resource Conservation and Recovery Act. That's a cradle-to-grave permitting scheme that includes permitting requirements for the use of hazardous substances, chemicals, toxic substances. And it says if you're going to create it, if you're going to use it, these are the requirements you have to comply with, and here are the closure requirements before you can dispose of it. So maybe there are satellite design, cradle-to-grave type of requirements that could apply to anybody who wants to launch a satellite into space. That if you're going to do it, here are this is how you have to design it. This is what you have to do when you want to shut down your operations, et cetera. So there are a couple of different ways to approach this issue too, I think.
And since you brought up recycling, I think that's this is a dark, gloomy picture that is painted about debris. You can actually have a potential opportunity on recycling this material. Just like we do, at least in my home, every Friday, every 2 weeks, that you throw things in the trash can and it gets recycled. And that's a trash could be an opportunity for somebody else. And this is happening right now. I mean, how do you go from trash to treasure? Somebody else's trash could be actually a treasure. So imagine this scenario. You have company A that, and this is the private sector doing this, that is able to pick up some of the debris that has a problem, unspent rocket or a satellite, then sells it to another company that removes some of the important pieces, but also cuts it and makes it available in a space station, could be the space station right now, the future one, then sells it to another company that can actually melt this, or a foundry that can turn it into could be a structure in space, like ISM, space manufacturing, or a propellant. And this is not far-fetched. This is happening right now. There's a company, Astroscale, that picks up your debris, and these are part of their plans, and they will pick up some of the pieces, probably larger ones, then goes to another company called NanoRacks that is doing this in the space station and is cutting this material, goes to a company called Cislunar Industries, which is here in Colorado, that produces a little pellet. This is solid propellant that can be used for electric propulsion, so that another company, Newman Space from Australia, can use it and actually has proven to use this as a propellant that can then be used by the same Astroscale spacecraft to continue picking up the debris. So this is an opportunity to convert trash to treasure, and in fact, debris to delta V, and one thing. And so these are opportunities that we should not. Obviously, there's economic issues. This is possible. There are legal aspects. Can you actually get a hold of material that belongs to another company or different country? But we should be aware of this type of opportunities where companies can collaborate to solve a problem that is affecting all of us.
And then, so one of the wrinkles, I love this idea. One of the wrinkles that I feel like we do have to address is the fact that space debris and all space objects belong to whoever launches it or to the operator. And so it is the property of the operator, even if it's a centimeter of space debris. And so I think that there needs to be some sort of regulatory mechanism whereby, like, when you're doing these types of recycling things, where you can easily transfer the rights to it. But I mean, there's a lot of other things. So what happens if there's a tiny piece, once you've collected it, that gets sent away and then it causes damage to something else? Who's responsible for that? Is it the operator, or is it the person who's collecting the debris? So I think that it's definitely stuff we need to start thinking about as this becomes more realistic.
So there actually is also another connection between space operations and environmental, because if we burn satellites up to deorbit them, that has environmental impacts, doesn't it?
Absolutely. And there are principles in place for the transboundary impacts of pollution. So if we think of debris as pollution when it burns up in space, there's the default norm in international law, which is that countries, sovereigns, can use their resources freely up to the point of impacting, harming another country. So you can't cause transboundary harm. But this principle is pretty weak, generally speaking. Usually it's a due diligence principle. It's that you've taken some steps to address it. If you do nothing, if you have no domestic laws in place to address transboundary pollution, then you're probably responsible under international law. But if you have some rules in place, the point of that being that not all countries are going to have the same level of development in terms of their legal systems. And so you don't want to create a requirement that every country, for example, have a Clean Air Act that is as sophisticated as our Clean Air Act. And so you allow for some of those differentiations among the nation states. So there are some principles at play, but often the international norms aren't as strong as one might want them to be to deal with these types of harms.
Anybody else have some thoughts on that? So one of the things we talked about a week or so ago was along the lines of your debris to Delta V, but was recycling parts as whole pieces and using them in construction of new facilities up in space. Is that a going concern yet? Or?
No, definitely. That's something that is being considered. And like I mentioned, this could be propellant, could be structures in space, but you have to also do a trace study with this compared to sending a rocket to remove this. Can you actually do it in space? It has legal implications, like Jillian mentioned. But definitely this is being considered because debris is a resource. If you look at it from that point of view, instead of burning it in the atmosphere, after spending thousands and thousands of dollars per kilogram to send it, why not recycle this material and obtain the titanium and the aluminum and the chromium and everything else? Solar panels, I think Milo can even speak to this, that can be, without having to go through all the process, you can probably recycle this. Maybe you can add to that.
Well, I think rather than trying to reach into the entrails of a bus and pull the particular thing that you want out, at least the panels are external. That being said, solar panels do age out because of radiation, and so, but I think if you're going to get parts, the panels would be the pieces that are the most naturally exposed, and potentially maybe you could think about more or less standard mounting and detachable hardware, that those parts could be detached separately and potentially recycled. It's an interesting question, and I think the question ultimately boils down to the economics, right? Because economics is always has the second to the last vote.
Yeah.
Physics has the last vote, by the way, but economics has the second to the last vote.
Good point.
Okay, no more. So I want to come back to the issue of debris again. That seems to stick in my mind as one of the key issues, because I read articles about like you said, the ISS having to move and so on. We've lost track of who caused what debris. Are there, we can recycle satellites. Are there technical methods now that we're getting to where we can begin to deal with the debris better?
I mean, I think the question is really about, do you know where it is, and therefore you want to avoid it? Because if you don't avoid it, you'll generate more
really
debris.
fast.
And that
Yeah.
can be, that's the worst problem. I think a lot of the older satellites may be less valuable, right? Just not as much interesting things about them, and that might be recyclable. And so I think one of the interesting questions I have is, and it'd be interesting if anyone here from CU would be willing to do a study like this, would be, has our debris generation materially improved per launch over the last 20, 30 years? I suspect the answer to that question is an overwhelming yes, but I don't have the data to back it up. Because in the old days, people didn't worry so much about bolts and umbilicals and stuff like that that came off. I think everybody who is working in constellations now is very attuned to the debris issue. And so is this problem getting better just because of normal incentives? And I think that's an important thing. And again, you know, we're blessed by a lot of great launch companies, and SpaceX has done a bunch of work in terms of debris mitigation in their launchers. I'm not sure Long March and those are in the same place. And then the question is, if the Chinese are going to launch their own very large constellation using a bunch of boosters that might not be so good with regards to debris management, where's the international forum to work?
Right. What are the regulations and who's the enforcer?
Yeah.
For some of this?
Right.
Are there any thoughts on that?
I personally would really like to see an UNCLOS type treaty for space. UNCLOS provides a lot of bodies that a lot of these issues are kind of hashed out. For example, like the IMO, the International Maritime Organization. They do a lot of this international work. And interestingly, the IMO is actually really great because they also incorporate industry. And so industry representatives are also very active. And so I think that we can use existing international law as an example, or as kind of a really good primer for how we want to be doing these things in the future.
So are we ever going to hit the point that we need orbital superfund sites?
Again, if you think the problem is getting better over time, then as the old stuff eventually burns up, maybe net, this problem will, I won't say solve itself, but it will get better. On the flip side, if you've got ASATs going on and collisions that could generate more debris, those are events that can materially change that, the quality of how clear space is. And those are things that we have to be very focused on.
I mean, I'm sure creating an international or a space superfund would be interesting. But one of the interesting things about Superfund, I think, this is our US cleanup law. It puts all of the liability on the current owners operators. So maybe the owner operators here would be, you'd have to think whether they're the nation states or whether it's the companies. But one of the advantages of Superfund, I think, is that because it's a strict liability statute, it doesn't care about fault. It shifts the obligation or the kind of hashing out of who pays what to whom back to the private actors. So you have a current owner of a contaminated site. The liability is on them, and they have to clean it up and pay for it. But if they can find the responsible parties, go back through and do their own diligence, they can make them pay. And so there's an incentive on those current owner operators to start doing all of the hard work of figuring out where did this piece of satellite, who owns this piece of satellite that caused the damage here to my satellite, And so you can force the private actors to kind of work it out without the governments having to be involved in a way. So there might be some, I wouldn't say it's a perfect analog to space because of the ownership issue, but it does create some interesting incentives for and efficiencies, I would say, if you create a strict liability type of regime in space.
Any other thoughts on that one? I kind of want to circle back to our original question about the carrying capacity and monitoring orbits and so on. Should there be an international organization that coordinates that? All right, now you mentioned Department of Defense in the US tracks space debris, and they're moving that over to Commerce. Is it possible for an international organization to do that? Should there be one, or?
I think right now, the US is the nation that's putting more things into orbit, so it has the incentive to make sure that we know what's where and how to avoid collisions. And I think it's always good to structure organizations so that incentives are aligned. I'm not sure what international ownership of that function buys you right now. But that going forward, there's going to be more nations operating in space and putting things into space. And so at some point in time, it may make sense to look at that. But I think the capability and the incentives are well aligned right now for the US to lead that.
Jillian, any thoughts on that front, or?
I do think that, so a lot of the US companies, like what essentially happens is they provide what's called ephemeris data it used to be Space Defense Squadron. I think eventually they'll move that to tracks. But the data is only as good as what you're giving it.
Exactly right.
And so I think that if we, like in the United States, I think that we have a robust system for dealing with this, and operators and the agencies involved are in sync and they're working in step together. I think it gets a little bit more difficult when you have other countries who have operators who don't necessarily have to abide by those. And so that ephemeris data, or if they're even providing it, is not as good. And then there's a lot of interesting IP issues associated with ephemeris data. And that's something that comes up sometimes, like how detailed do we want to provide for this? And so I think it's an important discussion that we do need to have, both about the IP and about sharing between countries and creating like an interoperable system.
I do think it's not generally known about how much we depend on self-reporting for ephemeris. And I think there are national security consequences of that as well. And so I think having active surveillance both in optical and with radar and other mechanisms to validate and to notice when things don't behave the way they're supposed to, there's an alignment there, right? From the national security objective as well as the space traffic control sort of objective.
So I think this is where the analogy to at least international environmental law starts to break down, because with most international environmental law treaties, there's an exception for national security. Generally, however, the militaries aren't the primary polluting sources in environmental law. So even though there's this exception for them, we're still addressing the problem. We don't have to worry about it. With space, I think it could potentially get a little bit more complicated and not quite as similar to the international environmental law context, especially when you have maybe some actors where the satellites that they put up or the services that they provide are quasi-private, quasi-military. So I don't mean to call out SpaceX, but if Starlink is in the sky, they obviously provide private internet capabilities, but they also support some military operations. Do they get an exception under international space law for their operations because they're national security exceptions, or how do you fit that into the scheme that's developed, because it might be very easy for some countries to just claim that everything is a national security issue, and so they don't want to be covered by whatever agreement that's come to. And so that could be too big of a hole that's created in these regimes. So, but I don't know how to deal with that.
Okay, we're just about out of time. Any closing thoughts from anybody on how?
I would just leave you with one thought. If you think the problem with debris is hard here on Earth, how are we going to deal with debris and get rid of it, how things are getting so crowded, try to look a little bit into the future and not so far out. You have the United States, you have Europe, you have China, India, Japan, all of them with plans to have a lunar base by the end of this decade or early next one. They're going to need infrastructure, they're going to need power and transport and communications. They're going to have to be able to communicate and pinpoint every location on the moon, on the equator, on the permanently shadowed regions, on the far side, and think about it, a place in which there's no atmosphere. So where does a lunar satellite goes to die? There's no way to reburn it. Where are you going to put it? This is a place that, according to the Outer Space Treaty, nobody owns the moon. So what are we going to do there when the time comes? So some food for thought, literally, because we're going to talk this on Munch and Muse tomorrow. So stay tuned.
Maybe a lunar landfill is what's required.
Lunar, that's correct.
Okay, so it's time to open up the questions. So per the Weiser rule, first question goes to a student.
Hi, Kaylee Lauder, recent graduate of Colorado Law. You mentioned that or space air traffic control. Who do you think is best situated to act as like a space traffic controller up there?
Right now, the function of collision avoidance is distributed, right? But most space operators want to make sure they don't bump into something. So the primary job is understanding where things are and keeping those things up to date so that entities who fly the spacecraft can avoid bumping into things and causing collisions. So I think the emphasis right now is on space situational awareness. The question is sort of, you probably don't need somebody to tell you to move if the data shows that you're going to run into a collision and you're going to have an incentive to move. So I think the focus is really, I think from my perspective, on space situational awareness and not directing traffic. I don't know if
Any other thoughts on that? Okay, open up to other questions and just remind everybody that when you get the microphone, state your name and your affiliation when you give the question. So we've got one right down here in front.
Thank you. Buyana Mushay, NTIA. I have an international policy question. How do you make sure, since space is a resource for the whole planet, and you guys are talking about other countries are starting to launch, how do you make sure there's an equitable access to the space for all the 180 countries that are there, and you are not causing disasters like what you're talking about? And it's kind of circling back to the environmental aspect. It kind of reminds me of like the CO2 pollution that industrial countries started pollute the air, and then all the other countries started to do that. So how do you make sure that's not going to happen? Is there any mechanism in international places that make sure that's not going to happen?
Yeah, it's a great question. I'm sorry to jump in, because we haven't addressed it internationally for climate change. Interestingly, so there are these phrases in international law that are often used to describe different things. The seabed, for example, is referred to as the common heritage of humankind. That means everybody has access to it and has a right to share in its benefits. So if one country starts mining the seabed, they're legally obligated, arguably speaking, to share in the benefits with everybody. All countries have a right to that. There was discussions when negotiating our climate treaties whether to call the atmosphere a resource, a common heritage of humankind, meaning if the United States, England, many developed countries, or industrialized countries, excuse me, have used the atmosphere as a carbon sink, then they should share those benefits with all countries. Well, that request to add the common heritage of humankind language into the climate treaties was rejected. It's not considered a resource for purposes of sharing the benefits. So it didn't work for climate. Maybe space will be different. I suspect it won't be.
Another, let me go to the back over on this side first. I'll get you next.
Greg Kopp, University of Colorado LAS. Curious, when you come up with regulations for
And
spacecraft,
Last is
Laboratory for Atmospheric and Space Physics. Thank you.
acronym rule.
When you're regulating spacecraft, are you going to be differentiating between different classes of spacecraft? I'm interested particularly in CubeSats, things that are inexpensive, scientifically useful, and can be completed on kind of a student's career time frame. But they generally can be considered maybe as space debris because they have no way of moving out of the way of some collision or doing controlled reentry. So to keep them inexpensive, kind of need to be treated differently from something much higher up and much bigger. So do you see differentiation between spacecraft classes and regulations applied to each of them?
You can start.
Okay, so there actually are. The FCC has done a really great job at creating what's called the small sat procedures. So that's anything under, I think, 180 kilograms with less than 5 years in orbit. It creates an expedited licensing process. However, they do still have to provide what's called ODAR, which is Operational Debris Assessment Review, I think, something like that. Which is an extensive amount of math and all of these other things, and you have to show exactly how you think the satellite will demise, whether it's going to burn up, depending on how large the small sats are. So they could be teeny tiny, they could be like the size of a skateboard, a little bit bigger. They will require various types of you need certain capabilities in order to not have to worry about other requirements. So one, for example, you need to have propulsion in certain circumstances if it's a certain size. And so some of the small sat procedures exempt the small satellites from doing that. And it's intended to ensure that these types of uses can actually occur.
Yeah, I would just say a couple things. The decline in the cost of access to orbit not only makes it easy to launch smaller sats, but also easier to launch bigger sats. And so I think the question about where payloads go, right? What's the evolution? We're starting to see a lot of bus providers making commercial buses so that you may not have to actually go build your own satellite anymore. You could put your radiometer or sensor on a commercial bus that may have scale efficiencies so that it has GNSS location and telemetry so that you can report your position to the ground very accurately. Again, I think I keep going back to situational awareness as being a really important thing. And so I think there clearly are different rules for different classes, but as the cost to orbit keeps getting cheaper and cheaper, I think you're going to see a different mix of spacecraft. And I actually think in some ways constellations like ours could actually host scientific instruments, and you've got bandwidth, you've got power, and do you really have to build completely separate sets of spacecraft? If we start thinking about the buses that are being used in constellations as a platform, I think you could do some really interesting things.
Anyone else care to hit that? Okay, next question. We've got somebody here who's been very persistent about giving the hand up. I'm sorry, Dan, I've missed you here. So right middle of the row here.
I'm Jessica Heim, University of Southern Queensland, but I'm based here in the US. Anyway, my question is about the space situational awareness and the orbital carrying capacity. A lot of times when I go to events, especially things that are industry focused, whenever somebody asks about, what is the carrying capacity of space? And the answer always seems to be, well, we'll have better space situational awareness, we'll have better maneuvering capacities, and that will increase the density that we can, have in a given orbit. But then the question is, that sounds like a really good answer, assuming that you know where everything is and that you can maneuver everything. But there's so many satellites that cannot be maneuvered. Let's say you have a hardware failure, and then, like Jillian was saying, just like the small pieces of debris that aren't trackable is potential to cause something to explode if it hits in it, things like that. And then add in the volatility of like geopolitical situations, things like that. So how do you arrive at like trying to figure out what's a safe orbital carrying capacity in a given area, given that you have all these wild cards that you can't predict that could radically alter a safe environment?
I'll try this. I'm not sure having a number is that useful. That is to say, the question of what's the theoretical max that you could have if you optimize all of these things is what do you do with that information? That is to say, I think one of the questions is anyone who's building things going into orbit, you have to deal with collision avoidance. You should be designing the bus, the spacecraft, the launcher to not release extra parts, right? The small debris that's in lower orbits will eventually burn up. And so the number of what is the max capacity, carrying capacity, changes as these things happen. So I'm more interested, rather than what the number is, what the curve looks like. And so I think, what can we do to increase that? And what is naturally going on that increases that carrying capacity because of all the changes that are happening in the industry already? So from a policy perspective, I know oftentimes in spectrum, people want like in broadband, what's the number that should be considered broadband? How fast is broadband? In reality, that definition changes over time as different applications, different user classes come in to the network. And so what you really want is to understand what that curve looks like and not just one point. So I don't know if that's useful or not.
I am so excited. I get to bring up my favorite topic right now, which is zombie sats. We had an incident a while back where a satellite got hit by a solar flare and stopped responding to hails. And so we couldn't, like the operator couldn't conduct any TT&C, that's tracking telemetry and command. And so it was just moving around in geostationary orbit, going into other people's orbital slots along the geostationary arc. And so it's kind of what you're thinking about. The really remarkable thing about it is that there was so much cooperation between different countries, between different operators. At one point, the satellite actually went underneath another satellite and blocked their beams. And so what they ended up having to do was the satellite operator who was above actually used the other satellite to transmit all of the stuff that they were doing while it was moving through their orbital slot. And all of that to say is a lot of this is about cooperation and making sure that everybody is cooperating in space to deal with these emergencies when they arise. And so I think cooperation and flexibility and just general international comedy are really important for making sure that even if we do have a lot of space debris, everybody's willing to work together to make sure that it doesn't create bigger emergencies.
Dan. All right, unfortunately, Dan, I'm not sure I can get to you. We're out of time here. So want to thank the panel. So thank you very much. Thank you all.